Hello, this is Mrs. Jackson, and this is section 3 of chapter 4 in Precalc, and this section is on arc length, radians, and circle sectors. I'm going to do this section in 2 different videos. The first one, I'm going to focus just on arc length and radians, and then I'll do a second video on sectors. Okay, so let's get going. So we're going to talk about arcs, and arcs are a portion of a circle. So a circle is a collection of points that are equidistant from the center point, and an arc is going to be a portion of that circle. And so if we think about the entire circle here, we talk about the length or the outside perimeter of that circle as the circle's circumference. And so when we talk about an arc being a portion of that, we say that the circle arc is a portion of the circle's circumference. The circumference of a circle is really just its perimeter. So that arc can be described by the measure of that interior angle that's making it up. So we call that interior angle the central angle. You'll hear me say inscribed angle as well, and I say that a lot, but it's really the central angle. So let me just move over here. So if you look at this length here of this arc, it's kind of dictated by this angle, this angle whose vertex is the center of the circle. So however big that angle is going to make, a large or small arc on the outside. So this angle really is dictating how big that is. So we can describe this based on this angle here, or we can also describe its length. And the length is going to be some kind of portion to the entire circumference of the circle. So we can also say that an arc has a length, and that length can be found using a proportion. A proportion is when we set 2 ratios equal to each other. And think of it this way. So the length of the arc is a certain ratio of the entire outside circumference, and the circumference of a circle is 2 pi r. So that ratio is equal to that interior or central angle x. Maybe I'll just throw a little degrees on here. As it is to the entire interior angle of a circle. And if we go all the way around the horn of a circle, that is 360 degrees. And so this should be kind of intuitive. So let me just do a few labels here. So this L here is arc length. And some people use a lowercase s for that. The 2 pi r is the circumference of a circle. And this x is going to be that central angle, or I call it the inscribed angle. And 360 degrees is the entire circle angle. So this proportion should kind of make some intuitive sense. So before we move on and start practicing using this proportion, I just want to mention that this length here, this length, is described symbolically as AB, and it kind of has like this little arc or hat over it. So that AB with the arc is the length. I'll just put lowercase cursive L here for the length. And also you might see maybe the little cursive M and then the AB and the hat. That really is the angle, the central angle. So if you see this symbol, it's really talking about this angle here at the center of the circle. Okay, so let's see how this works with an example. All right, so find the length of arc AB, that's how we would read this symbol, arc AB, if the measure of arc AB is 53 degrees, that means the central angle, and the radius is 5. So we're going to set up our proportion. We have L 2 pi r equals central angle over 360. If I cross multiply this up, right, to isolate L, I have L equals, I have my central angle x times 2 pi r over 360. And that 2 over 360 then is going to give us x times the radius times pi over 180. So 2 over 360 reduces out to 1 over 180. So that's what we're going to be using. We'll substitute in now. So L equals that central angle 53 times the radius, which is 5, times pi over 180. And I can simplify that. 5 over 180 is 1 over, let's see, 36. So this reduces to 53 pi over 36. And that is an exact length. If you have pi in your answer, we consider that exact. However, you could use your calculator as well and approximate. So if I use the pi button on a calculator and I multiplied it by 53 and then divide by 36, that's approximately 4.63, and we would just say generic units here since I wasn't given any inches or centimeters or something. So that outside arc length is approximately 4 6/10 units, but it is exactly 53 pi over 36. So this leads us into a discussion of a new unit of measure. So big topic and very important in pre-calculus. It's called a radian. So a radian is another unit of measure for angles. So up until now, we've pretty much entirely worked angles using degrees. A radian is another description of an angle. And a radian is basically a measure of that central angle whose arc is equal to the radius. So let's take a look at what this means. So if I say the arc length is equal to the radius, that means cursive L is equal to R. So when that specific condition occurs, then you're at exactly 1 radian. All right, so let's take a look at what we're talking about here. We've got our proportion. We've got the arc length is to the entire circumference of the circle, which is 2 pi r, as that central angle is to the entire degrees of a circle, which is 360. If L equals R, I can, replace, okay? I can replace one for the other, substitute. So I'll put in R here. And I see that R over R will reduce out to 1. They basically cancel. And so I'm going to solve here for my central angle. And when I do that, I'm basically going to cross multiply this 360 up. And hopefully you can see here that x equals 360 over 2 pi r, over 2 pi. And again, 360 divided by 2 is 180. So what is this saying? We have that interior angle in radians is 180 degrees over pi. So this is radians. So think about it. It kind of makes intuitive sense. If you think that outside circumference all the way around the circle is 360 degrees, we've always been actually using radians whenever we talk about circumference. So that entire outside has always been 2 pi r. 2 pi, think of that as 360. Whereas 180 degrees, half of a circle, semicircle, is going to be pi radians. And so if you're looking at this ratio here, you're looking at almost like the number 1. 180 degrees is equal to pi radians. 360 degrees is equal to 2 pi radians. And so if we take a look at the result here, then 1 radian is exactly 180 divided by pi, and I'll just put exact. And you could approximate. 1 radian is approximately, if you use the pi button on the calculator, 57.3 degrees. Okay, approximate. We're almost never going to approximate radians. You would always have typically pi in your answer whenever you're talking about radians. Okay, so it's going to become pretty important to convert degrees to radians and radians to degrees. And so take a look at a few examples here going from degrees to radians. Remember, the key thing here is if you want radians, radians will have pi in the answer. So that's a good way to think about it. Radians will have pi. And so you're going to take the degrees and you're going to multiply that. Since you want pi in the answer, you're going to have pi over 180 degrees. Because when you multiply that degrees, then degrees measure-wise or unit-wise are going to cancel in the numerator and the denominator, and you're going to have pi left over in your answer. That's how you know it's radians. So example, we have 135 degrees. We're going to multiply that by pi over 180. You're not going to go grab your calculator. You're just going to reduce this out to an exact answer. So 135 divided by 5 is 27. 180 divided by 5 is 36. I'm just reducing out. And I could see 27 and 36 are both divisible by 9. And so I end up with 3 pi over 4 radians. And you can do that with every single one of these cases. So you're going to have pi in the numerator. You're going to have 180 degrees to cancel out basically the units. I could just divide these both by 10. And then I have negative 11 over 9 pi radians. And 300 divided by 180. 30 and 18 are, let's see, both divisible by 6. So I have 5 pi over 3 radians. Last one. There are 4 45s in 180, so this is the equivalent of negative pi over 4 radians. Okay, so how do we go in the opposite direction? So convert radians back to degrees. Remember, if we want degrees out and we want the radians to cancel, then you want the pi to be in the denominator to cancel the pi in the numerator. So if we want to go this way, we're basically going to take our radians that has pi in it times 180 over pi. And you're going to get your degrees back. So let's do a couple of examples here. We want 180 up here and pi below. The pi's cancel. And we have both divisible by 6, so we've got 30 over 2, which equals 15 degrees. I'll come back to number 2 in a second. So you're just going to follow the same procedure. Multiply radians by 180 over pi. Basically, this is the number 1. 180 degrees equals pi radians. And so what do we have left here? We've got 60 times 2 is 120 degrees. And we'll move over here now. This is a little unusual case where you don't see the pi. So this is exactly 3 radians. You're still going to follow the same procedure though. So you've got the 180 over pi. And this time we're going to use our calculator. So it really isn't an equal sign here. In fact, I'm going to erase it. So this shouldn't really be an equal sign. This should be an approximate then. And if you use your calculator, 3 radians is approximately 171.9 degrees. Last one, we multiply radians by 180 over pi. We're going to end up with 45 times 5, which is 225 degrees. All right, so let's now try to find the actual arc lengths in certain circumstances. So this first one, we're given the radius, and we have the central angle in degrees, and we're asked to find that arc length. You'll also see this fancy word sometimes, the arc that subtends the circle. That just means whatever that arc is, portion of the circle. Also, you might see the lowercase s for arc length, and I never use that. I use cursive L, but you'll see definitely the textbook and the internet use S often. All right, so what's happening here? We have a circle. Let me see if I could draw a circle. I've got some kind of circle, and I've got a central angle of 215 degrees. If I try to draw that out, that's a bit over 180. So we've got 215 in here. Our radius is 7. And what we're trying to do is find this length out here. All right, so we move over here. We've got our proportion L is to the circumference, as that central angle is to the entire angle of a circle. And when we cross multiply, we end up with that angle times the radius times pi over 180. So if we start substituting in, we've got 215 degrees. We're going to multiply that by our radius of 7, and we have 180 times pi. And if you kind of reduce that out, you'll see that this reduces exactly to 43 over 36 pi. This is our length, and again, this is exact. And we can approximate that with a calculator to, let's say, I think it comes out to 26 3/10. And I guess this would be in inches, given that our radius was in inches. Okay, last problem. This time we are going to find the arc length, but the central angle that we've been given is in radians already, and you can tell that because there's pi in its value. Okay, so let me first draw a little sketch, and here we are. So if you think about it, 5, 6, that's less than the number 1. 6, 6 would be the number 1, and 1 pi is 180 degrees. So if we look at this, our angle here is just under 180, or a straight angle. So this angle is 5 pi over 6. We're told that the radius is 5 feet, and so we're looking for this arc length here. Okay, and so we'll go right back to our equation here, which is L. I'm going to go right to this one here. We've already simplified. L equals that included angle times the radius times pi over 180. I'm going to rearrange this just a little bit to show you something here. So we've got that included angle times pi over 180 times the radius. So if we look at this carefully here, that x is the central angle, and when we multiply that central angle by pi over 180, that's the central angle in radians. So to get this arc length, when we already have our central angle in radians, The only thing we need to do now is easy. We just are going to multiply our central angle, which is in radians, times the radius. Our radius is 5. So this arc length is going to be 25, 6 pi radians in length, or, so this is exact again, or we could approximate that using our calculator, and that comes out to be about 13 1/10 feet. Okay, so in this quick video, we looked at the definition of radians, we looked at how to convert to radians, and how to convert back to degrees, and we also introduced the concept of arc length, both measured in units as well as measured by the central angle that creates that arc. Hope this video helps.